To start an exam, click the Examine button and rotate your phone to be in the landscape position. The examination screen will appear, a blank screen with the heart and lung icon on the top left. Place the StatIO bell on the chest and press firmly, but there is no need for excessive pressure. The patient should take a deep breath in and out, and then hold their breath. With StatIO in place, press the appropriate icon to start either a heart or lung recording. Heart sounds will begin to be displayed. Record for 15 to 20 seconds. It is fine if a patient cannot hold their breath for the entire duration. During the recording, you should see a heart rate measurement appear. Tap the screen anywhere to stop recording. This is a recorded segment. To record another segment, perhaps at a different location, such as the pulmonic area, move the device appropriately and hit the heart icon again. The same process is followed when examining lung sounds, except press the lung icon to begin the recording. As the heart exam is being recorded, you can see a real-time phonocardiogram on the screen. The phonocardiogram is a visual representation of the heart sounds. The line in the middle of the screen is the amplitude line, which represents the volume of the sound recorded. You can see the two key heart sounds, S1 and S2, very prominent on this line. These are two peaks on the amplitude line. The way you tell S1 from S2 is that if the interval between S1 and S2, the systole, is shorter than the interval between S2 and S1, the diastole. In this example, we can see the two peaks, and being able to see the systole and diastole interval, we can identify S1 and S2. The color plot at the bottom of the screen is a spectrogram of the sounds. The color represents the amplitude of the sound recording, from red being the loudest and blue being the quietest. The height of the colored peaks represents the peak frequency, with the range of 0 Hz at the bottom to 800 Hz at the top of the screen. This information can be very useful in diagnosing heart sounds since murmurs are high-frequency sounds. Now let's take a look at some murmur examples. Under Patient Exams, you will find our ever-growing list of demo exams. Please note that we will review how to manage previously recorded patient exams at a later time. Here is an example of a holosystolic murmur. Note the S1 and S2 peaks labeled here capping off the systolic interval, and note the high frequency, low amplitude, and murmur throughout the systolic phase. As you can see in the spectrogram, this is a high frequency where the spectrogram peak reaches the top of the screen almost at 800 Hz. Now here is an example of an early systolic murmur. As before, the S1 and S2 peaks are labeled here, and note the high frequency and low amplitude murmur in the early systolic phase. The frequency of this murmur reaches halfway to the top of the screen, almost 500 Hz. As you can see from the examples, the phonocardiogram is very useful not only to identify a murmur, but also to identify the location and severity of the murmur, whether it is an early systolic, holosystolic, or diastolic murmur. StatIO also offers an assisted intelligence feature for heart exams. As soon as the heart exam is completed, StatIO sends the sound file over to a cloud analysis server, which interprets the sound. Once the analysis is completed, the StatIO icon glows and becomes large on the exam screen. Press that button to see the assisted intelligence report. In this case, you see the report identifies the analysis was able to find S1 and S2, and the exam is found to be probably normal. In exams where murmurs are found, our report will flag the exam as probably abnormal. Please note that this analysis is based on the phonocardiogram, and the final diagnosis will require a clinical exam for confirmation. The interpretation should be done by a qualified physician.